Alright, so today we're talking about graphing form of equations. There's three letters that you need to remember for graphing form of equations, and that's A, H, and K. Now every time you come up on these, A is going to be your vertical shift or compression, H is going to be your horizontal shift, and K is going to be a vertical shift. So when we go through these, you'll see these letters pop up over and over again. The only time you're going to deal with a different one is when you start dealing with trig functions, sine, cosine, and tangent, and then you'll get a B in there. So what we have first is just a line. So if we have graphing form of a line, it's pretty close to the slope-intercept form that you're used to. It's y is equal to a parentheses x minus h plus k. And hk is just any point that the line goes through. Now the movement looks reversed for the horizontal shift because it's always x minus h. But if we go through the point 2, 3, and we have a slope of 5, this is going to be y is equal to 5, parentheses, x minus 2, close parentheses, plus 3. So once you distribute the 5 and put it together, you'll have it in slope-intercept form. In this case, it'd be y equals x minus 7. So then the next one that we deal with is a parabola. And the parabola is y is equal to a parentheses x minus h squared plus k. In this case, hk is going to be the vertex. So if I have a vertex at 2, 3, and it's just a regular parabola, that's y is equal to x minus 2 squared plus 3. If they just give you the vertex and one other point, you can actually put the vertex in as hk and use your other point, like 0, 0, or whatever it is, put those in for x and y, and be able to solve for a to find out either your vertical stretch or vertical compression. Now, in the case of a parabola, if you have a higher a value, something greater than 1, it's going to be a slimmer parabola, and then it's going to be a wider parabola if it's something like 1/2, 1/5, 1/8. That's my vertical compression. The next thing that we have is a cubic function, and that's very similar to over here. It's y is equal to a times x minus h to the third plus k, and hk in this case is my center point where it comes up like this and curves like this. You don't have to deal with these as much, but again, if you have another point, you know it's cubic, you can find the a value by substituting in that one other point, solving it mathematically. Past the cubic equation, you have a square root graph. If you have a square root graph, it's going to be y is equal to a times the square root of x minus h plus k. Now a square root graph goes like this, so hk in this case is going to be the starting point of your graph. The transformations on a still are going to make it taller or less tall. It's a vertical stretch or a vertical compression along the same lines. Then we'll have absolute value. If you have absolute value, it's y is equal to a times the absolute value of x minus h plus k. And again, in this one, hk is our vertex. It's a lot like our parabola, except our vertex on this one, we just have straight lines that come up from it. And our a value on this one is actually most similar to the slope that we have over here on the line. So you don't have to do a whole lot of calculation if you have an absolute value graph, but if they just give you the graph and say, give me the equation based on this, find the slope, put it here, find your vertex hk, and plug it in here. Don't forget that this is always a minus here, unless you have a negative number. It's not worthwhile to put x minus -5, so you just put x plus 5. Aside from that, the only ones that you may make it to in the course of Algebra 2, you will have exponential equations. That's y is equal to a times b to the x minus h plus k. In this case, k is actually your horizontal asymptote. And then the h is again your shift, but it shifts where we are instead of being at 0, 1. In all of these graphs, where we have an exponential function, any number to the 0 power is always 1. So if this is x minus 4, it would be 4 to the right is where we're at 1 instead of being at 0. It just changes that value. We also have logarithmic graphs. That's y is equal to a times the log, and we just use base 10 on this of x minus h plus k. Again, hk, h is your horizontal shift of where that's going to be, and in this case h then is going to be that vertical asymptote, that line that you could never get to. K is going to be more where you're at, instead of 0, 1, 1, 0, because these are the inverse of one another. The only other graph that we've dealt with so far has been a circle, and that one is just y, or not y, sorry, x minus h squared plus y minus k squared is equal to r squared. R is the radius of the circle that you're going to be dealing with. The h is your horizontal shift, the k is your vertical shift. This is the only one where x and y are on the same side and they're both squared. So in this case, the k is also backwards from what you would expect. In all these other ones, you can see that the k value is on the opposite side of the y, and we're adding it. That's our vertical up and down shift. But on this one, the k is on the same side of the y, so we're subtracting it, just like we do with the h next to the x. So this one's a circle, and HK is the center of the circle. So if you have x minus 2 squared plus y minus 3 squared is equal to 9, then this is a circle that has a center at 2, 3, and it has a radius of 9. This should cover every graphing form that you're going to see throughout the course of Algebra 2, with maybe only a few exceptions. One more graphing form that I left off the earlier video that I need to do, and that is inverse. If you have an inverse equation or a hyperbola, that one's going to be y is equal to a times 1 over x minus h plus k. In this case, hk is actually the intersection of your horizontal and vertical asymptotes. It's still a shift to the left or right with the h, it's still a vertical shift with the k, and it's still compression or stretch with the a value there. But instead of your graph going like this, which is just 1 over x, if you have an intersection at 3, 4, that's going to be 1 over x minus 3 plus 4. So then it's going to be the same graph. It's just 1, 2, 3 to the right, 1, 2, 3, 4 up. Here's my center. And I don't touch that point at all. That's the intersection of my vertical and horizontal asymptotes.